So there's a bio in the packet, but Mike was nice enough to provide a spoken version of his bio, and it says, Mike Watson is VP of AI for Coupa Software. He is also an adjunct professor at Northwestern and the author of a couple of books. So we'll just leave it at that.
All right, that's fine. Perfect.
Thanks, Mike.
All right, thanks, Larry. It was faster than the setup.
I can do the long version of the bio.
Nah, it's boring. All right, so before I start, I'll just say on this talk I'm going to go, it's going to be broad on the different cases I talk about. I'm not going to go as deep as on any one particular problem. But if you want more information on that, just feel free to let me know. We good? All right, so I'm going to start off by how I define AI. Like I always think AI is kind of poorly defined, and I always use this when I talk to people in industry to help people anchor in on what it is that we're talking about when we talk about AI and how are people using the term. I think there's basically two definitions as I like to think about it. The first one that you'll see in the media a lot is I would call artificial general intelligence. So can I get a machine to think like a person? Can I drive a car? Can I have a robot that talks to people? If you listen to Ray Kurzweil, he talks about the singularity, like computers are going to take over. Like I think this is artificial general intelligence. Groups like OpenAI are looking at this topic. But I think if you talk to people in business, when they use the term AI, they're actually talking about something different. And I would define that as more practical AI. I don't think this is a great name, but it's kind of the one I've honed in on. It's like, what is practical AI? And I think it's all the stuff we've talked about here in this conference. It's like combining, algorithms with data, with computational problems, basically to solve practical problems. And so I think if you talk to people in industry, this is how they think about AI. I think there's another part of this definition, and that's the mindset. And when I talk to different companies, I talk about this mindset too, is that if you're going to be an AI company or think about AI, what you want to do is think about all the different problems that I have. How can I more creatively think about solving these problems? How can I think about using an algorithm instead of a process? So it's sort of being creative and coming up with new ways to apply these different algorithms into the business problems. So of course, if you think of this definition of AI as practical AI, it almost lends its idea to AI is kind of this umbrella term that encompasses a lot of different algorithms that do things that are in a smart way, but aren't meant to be like any kind of general intelligence. And so I've written a couple articles, one recently in ORMS just about this topic if you want more information on it. But basically, I came up with this idea, we came up with this idea because it was like the oxygen in the room is kind of sucked out by deep learning and reinforcement learning, and there's actually more algorithms that you can apply to your problems, and maybe these two algorithms aren't necessarily the answer to any particular problem. So, I would include optimization, regular machine learning, simulation, statistics, so on. Like other kinds of algorithms could fold under this umbrella term. So I like this, not because it's how I think about the definition, but I think this is how people in industry are actually talking about it. And so when someone says AI, I don't automatically think, well, we need a deep learning expert. It's like, all right, let's talk about your problem and see what kind of algorithms will work. All right, so that's kind of the definition. Now I want to get into some different use cases and kind of talk about, where have we seen creative use cases or interesting use cases of applying ML in the supply chain or, to business problems in general. I'm going to start out with a trend that I see, or one of the things, something that I think is important is the ability to combine prediction plus optimization to solve a particular problem. And I bring this up often. We've talked about it here quite a bit when we talk about reinforcement learning, but in general, I see a lot of people in the data science community, they sort of forget about optimization, and it's actually a powerful technique to solve a problem. And it was kind of funny because someone asked the question on Larry's talk about the red lipstick. And so this case study is from a beauty supplier who supplies lipstick and other beauty type products in South America. They had a catalog company, and it was, I think, a classic example of prediction plus optimization. So the prediction side was they sent out these catalogs to 13, 15 different countries. The catalogs went out once a month, and so the idea was they had to do a forecasting system, like a machine learning forecasting system, just to predict what's going to sell well when it's on page 1 versus page 2, and should they do a discount on this? Should they do combine these two products together. So kind of classic machine learning there, and then followed up by optimization. And I think the optimization did what you'd expect is like, all right, let's put the ads in the best place. So as we lay out this catalog. But the second one actually turned out to be almost more valuable, and that was, how do I just automate laying out these catalogs? Like, just automating the catalogs is very hard with all the different rules that you have, and optimization is actually a good technology for doing just that, laying that out. And then as I was listening to the presentations and knowing that I had this slide coming, and a lot of our presentation themes today were like, let's not do sequential optimization, let's do it all together. And I was thinking about this particular project, and it was like, we like any one of these projects, like the machine learning, like barely crossed the finish line. And then the optimization part of it barely crossed the finish line. These were like super hard projects just to get these two things separate. I couldn't imagine trying to even put them together. We're probably, the research we're talking about here is like 10 years away from combining these kinds of things. So I think it's important to have this in our toolkit. All right, so that's one. The second one is, I like to think about the idea of machine learning as, can I solve something that's new and different? And this one just has a tiny little twist, but this twist came from trying to do a forecast of something different. And the something different was predicting orders, not demand. And so the problem came from a CPG manufacturer who sold their product on Amazon. And Amazon was this big and growing channel. And the problem that they were facing is that Amazon was notoriously erratic with what the order was going to be. So that, Amazon could have a forecast what they thought the order might be, and they'd send that out a month or 2 months in advance, and the order would not look anything like that. And then, of course, the company was punished for not following the order. And so what we did here is basically had a machine learning algorithm that tried to predict what was Amazon going to order next week. So I'm not looking at demand. I'm just trying to look at what are they going to order. And it was looking at, obviously the historical demand was a feature in this, but it was also like, how many page views was Amazon getting for my particular item? What kind of inventory did Amazon have? I think, another way to think about it, we used machine learning to basically reverse engineer what Amazon's order algorithm was so that we could come up with an answer. And we kind of came up with this, quartile regressor where we're trying to figure out, what's the probability that Amazon's going to order 500 or 1,000 or 2,000. So I thought a pretty interesting solution to a different kind of forecasting problem. And then, of course, followed up by optimization. So it's one thing to know that Amazon might order 2,000 with some probability, but then the question was, what do we do about it? Do we transfer goods? So you can see down below, it's the solid line there was showing sort of how much inventory we had at these different warehouses, and then the pink bars were like, well, this is what Amazon could order. So the question is like, do you transfer stuff? Do you run overtime in your factory to sort of meet this demand, or you just take your chances? You're just going to take our lumps. It's too expensive to move anything. Let's just sort of roll the dice and see what Amazon actually orders. So I thought, interesting example, again, sort of the sequential stuff, but what was different is like predicting something new and different. Another one that was inspired by, this was some original research at Northwestern that we picked up and we used and applied to different companies. It was about matching different players, and in this case, matching shippers and truck drivers, basically. So shippers and carriers, and trying to come up with what's the price. So oops. It's not an actual laser. Oh, okay. Oh, gotcha. Okay.
There you go.
So basically it's looking at, the cost per mile, and I have two curves. So basically I have enough data on the market to look at, this is the carrier. So as the cost per mile goes up, the carrier is more likely to accept it, which is obvious. Like the more you're going to pay the trucking company, the more likely they are to say yes. And then we've got basically the opposite curve for the shipper. The more expensive you quote the price or the price in the market, the less likely, they're more likely they'll go somewhere else, right? They want to pay less. And then so, this is from the view of the broker. And the idea here is that, all right, once I know these two curves, I can do some kind of, quick calculation, some quick optimization to figure out, what price should we quote when we're trying to match suppliers and buyers. So I think another, nice application, try to price out sort of what these different players in the supply chain are willing to accept for price and come up with some answer. All right, and then we took this idea to trucking companies. Like Landstar is a good example. So Landstar, so you might have seen their trucks driving around the road. So they're set up in a pretty unique way. The truck drivers are actually independent business owners, and so they don't have to listen to what Landstar says. The truck drivers can do what they want. And so basically, we took the idea you saw on the previous slide and then combined it with some other things to help the driver decide, which routes will they take and which loads will they pick up that help them optimize their personal revenue, which is, I think, an interesting way to think about the problem because, Landstar wants, obviously, their drivers to stay, and they thought the way they get their drivers to stay is if they picked up and could deliver good loads. And it's also interesting in like, can you take these algorithms and put it into, an app on a phone that a truck driver could use and say, yeah, these are the routes that I want to pick up. All right. The next topic I want to talk about is like, how can we complement inventory? So we've heard a lot about inventory over the last couple of days, but I think this is a little bit of a different twist, and it's how do I complement my different inventory system solutions by solving some different problems that are kind of related to the inventory problem. And the first one here I want to talk about is trying to predict stockouts. And so what you see here are basically two different inventory patterns showing how much inventory I have of two different SKUs. And I think the first thing that, this shocked me too when we first got access to this data. We had, 50,000 SKUs from this company looking at their inventory patterns, how much they had. And so I was expecting to see like, that sawtooth pattern that we always draw. And these are probably the closest two things I found to the sawtooth pattern in the whole data set, which I thought was kind of interesting. It's like, I don't know what they're doing something kind of crazy on their inventory policy, but this is what it looks like. And then the next step was think about, okay, there's a whole other project we're worrying about, like let's set the reorder points and sort of do all that. But what we wanted to do also was say, can we predict a stock out? And the way we were thinking about predicting a stock out is, can I use all this pattern and then find, these times when I stocked out, and as I look across SKUs, can I start to see patterns of something that's going to stock out? Some item, and can I do that with a week or 2 weeks notice to see, like, has there been a change in some kind of trend? Is a shipment not shown up, or is demand sort of like starting to be more, steeper than I thought it was going to be? And I think this is, I think a nice complementary approach, because oftentimes, when we talk about inventory, in theory, it's like, I want a service level of 95%, or this is my back order cost or lost sale cost. And I was talking to someone at Coca-Cola, and we were kind of talking about stockouts and service level, and he's like, the reality is, when there's a stockout, like that's a huge, painful event that everyone hates to go through. Because you get yelled at by your customer, you don't feel good that you're putting the right stuff on the shelf. And so the idea was, can we come up with other methods for sort of figuring out, like, all right, we might be stocking out of this item, and it sort of complements whatever we're doing with the inventory optimization. So that's one complement to inventory. And the other one, which I think is a different twist too, is using machine learning to help with inventory integrity. And so this is just trying to figure out, how much inventory do I actually have? And then more importantly, as inventory is disappearing in the system, why is it disappearing? So this was a retailer that we worked with, and they had multiple steps. So product would come into one warehouse and then go to another warehouse and then go to the store. And so there was all this receiving and warehousing and shipping, and product would disappear along this chain. And so they'd already invested like lots of money in security cameras and all this kind of stuff, and they were still having this problem. And so the idea is, can I start looking at the pattern of data, sort of what's coming in, what's going out, the type of products, and so on, and figure out, where are we losing inventory within the system? Like, what's sort of the root cause of where this stuff is disappearing? As we dug into the data, the other thing we found is that we called it inventory integrity because, like, it wasn't just loss. So sometimes we saw that, 6 things came in and 8 things came out. We're like, all right, so how did 2 new things sort of materialize in there? And it's sort of trying to track some of those problems. So again, another way to sort of think about complementing your inventory systems. I think, some other more simple ones I didn't put a slide on would be like, can I come up with better lead time measures and lead time variability and things like that? So there's nice machine learning techniques there that can also sort of feed these inventory models. All right, so this leads to more general approach to root cause analysis, and I think this is good use of machine learning and the data that you may have available. And one of the ways that I've found when I talk to the customers that I talk to is that, if they're sitting on this pile of data, is to say, what would Google or Amazon do if they had this data? And it sort of gets people thinking creatively. And one of the creative things that came out of this was thinking about understanding the root cause. And this is for, think about online delivery. So you order something online, and then it ships to your house, and you have some promise when that thing is going to show up. And so what you're looking at here is the features would be this timestamp. So actually, companies have pretty good information on all the timestamps for the orders going through the system. So, you click buy, and that's a timestamp, and then somehow, at some point from when you buy it on the website, it gets released to the ERP system. Maybe there's a fraud check. And then from there, the ERP system, cleared on the fraud check. And at some point, it releases it to the WMS, the warehouse management system. And then eventually gets picked. And then somehow it gets picked up in your warehouse. And then it gets delivered. So you have all these different steps. And if I collect all that data, I can start to ask the question like, all right, when something went wrong, what happened? Like what stage did it fail? And then you can layer on top of that all kinds of other features, like, what kind of product was it? What stuff was purchased together? Where was it purchased? All that kind of information. And so the idea is that I take that and sort of pull it together and build basically this root cause engine. And I think, the root cause engine, the way we want to think about it is that the first thing it's doing is basically looks backwards in time. So it's like, all right, all this stuff failed. What was the pattern of stuff that failed? Like, what were the 3 or 4 trigger points that the things had in common for why it showed up late? Actually, you can look at, why did it show up early too? Because early show up for, expensive items, not good either because it sits on your porch and you weren't expecting it and it's a $500 item. So you want to make sure you don't do that either. And so that's sort of the first step is look backwards, figure out the root cause and maybe address that. And then once the system is up and running, you can start looking forward and say, well, now I've seen these 3 triggers for this particular item. It hasn't shipped yet, but it's on its way to being late. Should I do something different? Should I expedite it, pay some extra money, pay some extra attention to this particular item to make sure it moves along? All right. It's root cause. The other big one, and I'm seeing this a lot at Coupa in general, is risk management. So, obviously when things went wrong, everyone started thinking about it. I need to make sure that I manage risk in a better way or thinking about it in a different way. There's all kinds of different ways to do this. We did a talk with McDonald's a couple years ago at a conference, and they were thinking about risk. In McDonald's supply chain, if you know anything about that, it's like they don't actually own or move anything. So they sort of outsource the whole thing. So one of their big risk factors that they care about is management of their brand. So even though they don't move it and they're not responsible for it, if it fails, they get blamed for it. Like it's McDonald's that makes the headlines. And so they wanted to do some basic things like a news feed just to figure out, all right, what's the world saying about McDonald's? What's the world saying about all my suppliers around the world? What are some potential problems in some different geographies? So there's that aspect. And then even deeper, let's start to look at, their supply base. So they have this huge supply base. They do tons of audits. But, the audits are, think about, all kinds of small, mid-sized suppliers possibly. So tons of manual audits with all these different text fields. Can they read those audits? Can they read reports about, what their suppliers are doing to understand, like, all right, who might go bankrupt? How are suppliers doing? How are they doing on delivery and stuff like that? And the idea is like, all right, can I cluster my suppliers into different groups? And then, maybe target, for extra audit some of the groups that are declining, aren't performing well, et cetera. Just sort of a way to sort of help figure out, all right, how do I target where I'm going to improve? And then finally is also looking at contingency planning. And we do a lot of this at Coupa in the sense of, looking for where are your nodes that are critical. So where are your bottleneck points in your supply chain? And how do you make sure you have, dual sources, dual ways to get product places? We saw a lot of this with, all the port congestion is like starting to think like, can I actually move my shipments from going from one port to another port, which turned out to be harder than I thought it was going to be, but that was a hard problem. Or can I shift stuff that I was going to put on a boat and can I put it on a plane? So looking at those kind of issues. All right, and then the last one on these practical cases is sort of new problems. I talked about this in the panel. This was the idea of safety. Like, can we apply this kind of stuff to look at safety or driver churn? We did this in the railroads where you have all this data and you can sort of flag certain people who might look like, they might be prone to an accident. I saw a similar talk from United Airlines, and they were doing a very similar thing, looking at their ground operations and sort of being able to send out very tailored signals to the ground crew. So, what United was doing before was just basically like, every day, like send out a note like, please be safe. And then what they switched to is like, oh, can we tailor that to say, okay, here's the load that you're going to expect today. Here's the weather in your region. So here's very specific things that you can do to stay safe. And so sort of tailoring the messages to the specific situation. All right. So that's a couple cases just to paint the picture there. And then what I want to do now is talk about, all right, so who's this funny company, Coupa? I have to admit, when Coupa bought our company, Llamasoft, like, I had to look up Coupa, like, Coupa's buying us. Who's Coupa? So I didn't even know. So who is Coupa? And then this is going to lead me to talk about a new source of data, which I think brings up some new AI opportunities for us, or some new things that the research community can touch on. And Richard, this kind of hit some of the things we talked about last night, looking at bakery data. So you'll see some reference to this here. All right, so who's Coupa? So we're in this category called business spend management, which is basically looking at all the spend data. So Coupa's goal is like to look at all the data that a company spends and help them manage that spend better. Basically, how to get the value out of all the dollars that they spend. And we think about it in terms of sort of different ways you can spend. You can spend money on, just buying product, procurement, legal cost. You spend money on risk. Treasury is sort of managing your cash flow. And supply chain is where we came from, or where we added to Coupa from Llamasoft. And so, people don't know Llamasoft, like, we're a company that does, network design, inventory, routing. And, this is kind of an example of a map, like where should you locate things. It looks at both cost and greenhouse gases. It also does things like routing. So here's a little case study where we're looking at electric vehicles versus gas vehicles to see, what's the payback period in terms of that. So that's a little bit about Llamasoft. But then what Coupa does, and I'm going to get to the interesting thing on data, is basically we kind of have a core of like, how do you actually transact spend within your whole business and supply chain, and then more advanced modules that sit around the side. So that's one aspect. But what I wanted to talk about is the way we've done this is we've been sort of cloud first from the beginning, and this is way before I got here, but Coupa, to their credit, has focused on building this community of data. And so most software companies don't think about this, but this gives, I think, for the research community, this gives us a new look at sort of how you can think about data. I think Coupa was onto something when they thought about this. So they own the data, and the idea is that every customer contributes this data, and then it gets anonymized, and then it gets used again for the benefit of everyone in the community. And so the way we explain this or think about it is analogous to how the Waze application works. So, if you use Waze, you're basically contributing your driving to the data, and then it gets anonymized, and then it comes back to you in terms of better direction. So everyone's contributing data to this community, and then everyone can benefit from the data that we all provide. So that's sort of the general idea. And then, but in this case, it's going to be for enterprise company data, like how can I look at all the data that someone's spending and sort of have this accessible for everyone. And I should point out, is like, when we even feel like, we'll even say this, is that we're at the very beginning of this. So I think we're just kind of starting out on this little journey. And as I was thinking about this, it was like, the way I feel like it's like it almost revitalizes the term big data. So I'm a little nervous talking about big data because it's like, all right, that term went out of style like 5 years ago. No one uses it. But it feels like this community data is like, all right, let's revisit that. And if we look at, what was the old term big data about, I think this book was probably my favorite, sort of giving it a good definition. It basically said there's two things. It's one, well, big data can be the universe of all the data, or two, think about data as having more, the data itself has more value maybe than the process that created it. So you might be, generating data from some process, and actually the data is more valuable than your normal business. And so those are kind of the two big ideas from there. The universe of data, a famous example that they had in the book talked about monitoring premature babies, and sort of instead of looking at, they're hooked up to all kinds of monitors, and usually that data just disappears. And instead they collected all that data so they could figure out, okay, are there patterns that we can learn from? And then the second one is the value. And this comes from companies like John Deere. the tractor manufacturer, where I think if you talk to John Deere now, it's like they're almost more of an IT data company than they are like a tractor company. And so they sort of transform that way. So that gives you the two ideas there. And then our CEO had a book on sort of bringing all this data together. But the idea is like think about communities of data. And so think about communities of customers who are all contributing their data and how can we benefit. And so we saw this example from Waze. But recently in the Wall Street Journal, a bunch of banks were talking about, can we share our data to prevent cyber fraud? So this is a good example of like, because banks have been notoriously bad at sharing data. Banks are now deciding like, all right, let's get together and so look across the whole community and figure out, are there opportunities here to prevent some kind of fraud? And so we'll all contribute and then we'll all benefit. And so how are we doing it, or some of the things that I've seen? So one of the things that we're doing, we partnered up with Accenture to look at child labor in the supply chain. So start thinking about kind of like a neighborhood watch, like any one company's supply chain, hopefully not many companies have child labor in their supply chain, but what you want to do is if you have this community of data, you can start to spot suppliers that are likely to have child labor, or if one company reports child labor, other companies in the community can benefit from that. It turns out it's not easy to predict sort of who has child labor, and then companies that are in violation of that are also pretty tricky about, having different names and that kind of stuff. And so there's some interesting algorithms that are under the hood there to try to figure out, all right, these two companies are actually the same company, and this one had problems, so this one probably does too, and let's raise that flag. So there's that. Closely related to that is supplier diversity. So we're talking about a little bit about fairness yesterday and today, and supplier diversity is something that we see lots of customers talking about and wanting to do. So there's, just having community data in itself, just data helps with supplier diversity, just figure out, okay, which suppliers are diverse. But it also, we haven't got there yet in terms of the algorithms applying, but we have plans to sort of think about, all right, how can we use algorithms and machine learning to help companies sort of be proactive and figure out, how are they going to increase their supplier diversity? So, which categories am I likely to purchase in for a diverse supplier? Which companies in the community might be good for them to try to pitch their wares to so that they can increase, the diverse suppliers can grow their base, and then businesses who want diversity can sort of be introduced to a wide range of suppliers. And then this one is, I think, an interesting one too for the research community, because this was just getting started, and there's lots of opportunities for linking companies together. But the idea here is sourcing together. So once we have this community of customers who are buying things, and think about, they want to buy transportation services, or is there a way that they could bid on transportation services together, maybe share some trucks, maybe share some warehouse points, et cetera, so that they can, both negotiate better and the suppliers can get some economies of scale. So I think, we've definitely done some sourcing events because we have the community data, but right now it's been sort of manual, and I think there's some opportunity here to, do a little bit more. So pull more, do a little more interesting analysis to sort of make these things better for both the buyers and the suppliers. All right, and then I touched on this one too in the panel, is looking for fraud, risk, errors, basically at the transaction level within the supply chain. And so the idea here is find different types of problems that can happen, like duplicate invoices is one, where then we can sort of track that and start to look across the community to see, okay, do we have problems, or do we see problems with duplicate invoices? The second one, which is more fraud related, is looking at requisition limits or expense limits. And so a manager might have a limit of $50,000, and then if you start to see, well, this manager has a lot of transactions that are like $40,000 plus $40,000 that look like they should be $80,000, but they kind of came in as two $40,000 ones, and so they cleared that hurdle. And so the idea is like, all right, can we start to detect those kinds of patterns? And we think, the big fraud that you see about, so when you read about some cases like, this person has stolen $50 million over the last 10 years, it's a lot of using some of those limits and then maybe even collaborating with others within their organization to sort of get the right approvals. And so it's using algorithms to sort of tease out or what are those patterns that are, might be likely to be fraudulent. All right, and then I'll wrap up here with sort of getting the value. Like, how do we see the next step in terms of actually realizing the value? I like this book quite a bit. At least the first 120 pages is good for like thinking about, all right, how do we operationalize AI within the organization? And they kind of have 3 points. Is that you see companies that need to build this data layer. And we talked about UPS building the data layer of, before they could do some of the routing. So how do you build this data layer? How do you build the algorithm layer on top of this? And then finally, like the software layer to actually get the thing deployed and get it used. And they have this little curve. Not sure totally buy into this, but the idea is if you have a digital operating model, is you continue to add customers, growth, etc. You don't add this incremental headcount cost and things like that. And then I think there's 2 important kind of roles that we've seen or ways that the companies implement this. And Stitch Fix is a great example of this. So they had this guy was the chief algorithms officer. I think he's retired or moved on since in the last couple of years. But he was right there from the beginning. And the idea was that Stitch Fix viewed themselves as sort of a digital first company. So that when they were created, it was like, we're going to have a chief algorithms officer. We're going to be about collecting as much data as we can to sort of make the business as strong as possible. And so this is like mindset. Like, how do we think about a digital first company with the right mindset to make analytics possible? And the second one, and we often got this question too, as companies were trying to figure out, how do I build this capability? And the obvious answer is like, all right, let's hire a bunch of data scientists. And we thought that there's actually a more important person than just a data scientist, and this is this role of this translator. So someone who knows enough about the data science, like can understand sort of the pros and cons of the algorithms, probably can't write it, but they also understand the business. So they can kind of match up those 2 different groups. And you need someone who can talk to the business about what AI does, and you need that same person to be able to go talk to the machine learning people to say, this is what we need to code up, and this is what we need to build. So we found that that's super important role if you are building up this capability in-house. All right, and I'll wrap up with that.
Questions?
I was curious if, in the work you've done, if you've seen the need for supplier agility or manufacturing agility to partner or to work with inventory logistics agility. In other words, are those 2 worlds evolving similarly, or do you think there's more pressure on one or the other in the situation we're in, or in the new evolving world of the consumer?
So certainly I've seen, there's definitely been projects that were almost linking manufacturing agility to distribution agility. Sort of thinking about, can I do routing and plant scheduling at the same time? Basically to get that agility to meet the customer needs. So I've certainly seen things like that. For companies that haven't been, can't be quite successful at too much manufacturing agility, is sort of thinking about, all right, let's put some inventory buffers in there so that we can at least have the inventory so that when the orders come in, we can be flexible. But yeah, I don't know if it goes one way or the other, but definitely a lot of sort of joint work in terms of let's make and ship as quickly as possible. Yes.
Yes, I had a question about the banks sharing their data to prevent cyber attacks. So is it that they don't have enough data, a single bank, to do this detection, or is it because is it the data that's the issue, or they want one person to solve the problems for all the banks?
I got the impression it was more the data, so that I'm not as familiar with that. That was just an article, but I think it was the data, because but the fraud work that we do, like any one company probably doesn't have that many problems with duplicate invoices, and by having all the data, I can actually have a bigger data set to train against. So that gives me there's a training advantage there. And especially for fraud, like it feels like fraud is hopefully rare enough that you sort of need that data so you can train on it. I've also sort of thought, like, when we think about this community data, like training reinforcement learning algorithms, it's like, all right, now I have more data to sort of train those kinds of things on. And so there's some benefit there, I think. Perfect. Anything else? Any more? Oh.
You have a question? Online?
It's like wasn't predicting elders a good cause of bullwhip. So maybe it's just a comment and not an actual question.
Yeah. What was the question again? Can you read it or comment?
Yeah. So it says, wasn't predicting elders a good cause of bullwhip?
Predicting orders a good cause of bullwhip?
Yes.
Is that a question for Mike, or that's left?
Oh, maybe that was from the Amazon stuff, like predicting the orders that cause the bullwhip effect. I think the problem they had was that Amazon was so unreliable, and then even if they were expecting to order 500 and Amazon ordered 3,000, Amazon would still yell at them for shipping 500, and they'd be in big trouble. And then it actually, Amazon's algorithm is even worse than that. Like once you miss once, then next week Amazon's going to order 3,000 because they don't think you're reliable anymore, and so it just creates this unending cycle. And so I guess that's kind of like the bullwhip effect, or something you don't want to have happen in your supply chain. Perfect. Anything else? All right. Thank you,
Mike.
All right.